This is one of the world's largest earth movers, the dragline. And how many people does it take to make it work? Well, in this video, we're going to show you everything about the process. Pop the breaker. Welcome to Beulah, North Dakota. While seemingly unassuming, this place is a big deal thanks to what lies underground: coal.
I'm kind of a big deal.
Which produces power for millions of Americans. We're spending the day with North American Coal at their Freedom Mine, which produces 12 million tons of coal annually. Operating to feed the Antelope Valley Power Station since 1983, the mine must run 24/7, 365 to keep the people of North Dakota and beyond comfortable and warm. Such a mighty task requires mighty machines, and North American Coal runs the mightiest earth movers in North America. Not one, not two, but three Bucyrus Erie 2570W electric draglines, which is what we're exploring today. Large draglines have served the American mining industry since the 1950s, operating anywhere from Wyoming's Powder River Basin to Pennsylvania's Anthracite region. As America grew, so did its hunger for resources and power, requiring manufacturers like Marion and Bucyrus Erie to build what became the largest earth movers ever constructed. The most famous of all was Big Muskie, weighing 27 million pounds and wielding a 220 cubic yard bucket. It began operation in 1969 and continued until the 1990s, when its mine shut down and the machine was sadly scrapped. Fortunately, companies like North American Coal have rescued many draglines from the same fate, thanks to a world-class dragline operation and maintenance program. Most of theirs are older than I am, yet still look new and operate without issue around the clock. Why are these beasts the perfect machine for coal mining? At NACCO, they use a process called open-cut surface mining. The mining company works one narrow strip at a time, often only a few hundred yards wide, but potentially miles long. The coal lies underneath what's usually about 100 feet of dirt called overburden. The faster and cheaper the operation can remove this material and uncover the coal, the more economical the power they can ultimately produce. Thanks to the sheer size of draglines combined with their electric power, there's no cheaper way to move giant quantities of overburden. And even better, thanks to the strip mining model, while the draglines dig for coal in the newest strip, they simultaneously place the earth in the formerly mined strip, allowing for almost instant reclamation. The draglines we're visiting today wield 123 cubic yard buckets and average about 60,000 cubic yards of earth per 12-hour shift. To move so much earth, the machine itself weighs 6,235 tons, spread across a width of 110 feet. To scoot the machine along, which we'll see later, the machine has two 70-foot shoes, and the boom, positioned at a 35-degree angle, reaches 340 feet. This ain't your grandpa's earth mover, unless your grandpa ran draglines. And since these are so old, I guess your grandpa could have run these exact machines. How the heck does such a monster operate? Well, for one, it doesn't need only one person, it requires three, who must work in unison all day and night to keep the machine swinging. There's the operator, who works the machine itself, the oiler, who performs constant maintenance on the machine, and finally, the groundman, who clears the way, keeps the power cable safe, and serves as the operator's eyes and ears on the ground. Thanks to the folks at North American Coal, we spent 2 days following dragline crews around and putting cameras in every nook and cranny we could find. While we were always safe, the cameras were sometimes not so much. On day one of the trip, I had a speaking gig in Bismarck with the Lignite Energy Council, so Wyatt and Drew reported for duty without me to catch shift change at 6 a.m.
Sport mode. Oh no! Not my side!
Let's first catch up with Josh, who operates one of 3 draglines on site.
This would be considered overburden. Taking it down to coal, what you see, the rest of the pit there, that's the coal we've uncovered so far.
How deep did you have to get before you get to the coal?
I would say we must have about 80 feet of cover here that we're taking. Overall, with the total, must be close to 100 feet or so right now. Where you can see what I'm digging on right now, that'll take about 1 shift, and then we'll walk back and start another lift, and that'll consist of taking the dirt we're sitting on right now all the way down to coal. This is all solid rock right in front of the bucket right there. You got to try to ease into it. We already lost a couple teeth. We're trying to avoid that. So this right here, this is our Pegasus program screen, and this actually runs off GPS, so it's given our position of where the dragline is and which direction we're pointing. And some of the lines in here are like outline our pit.
Gotcha.
The edge.
All the colored lines?
Yep, like this would be the edge of the coal. This line here, and this line that we're close to sitting on is the low wall line, the bottom of our high wall. And this here will be the key, the top of the high wall where we start to cut in. Take this section of dirt that we're sitting on right now, we'll start cutting right along that high wall over there. This screen is kind of more of the operations of the machine. If we have any faults, they'll pop up on here. Simple things like the machine hours, how much hoist rope and drag rope, our wire ropes here, how much we have out. Then when we go to walk, we'll go into propel mode. And then here we control how much water we're spraying on the ground. We spray water down as we walk so that the tub slides across the ground easier. 1 step takes about 41 seconds, and 1 step gets you 8 feet. When we go back on a new lift just on a regular day, that's only about 19, 20 steps. So that's only going 160 feet at that time. Now, when we get done with the pit and we move to another area or the other end of the pit, deadhead the machine, that can be, a mile or more. So that sometimes will take a couple shifts. Okay, so the left stick, all that controls is when I pull it back towards me, that pulls those drag ropes, those wire ropes, pulls them in, pulls the bucket in, and then forward is out, and up with the right stick. To go up, pull the stick back, the right stick, and forward is down. And then also on the right stick, left and right is swing. And you can kind of see how slow the reaction is to move it. I'm, full reference left there, and it takes a while to get moving. About 1.5 years I've held the operator position, I guess. So, been here since 2009. You kind of always work your way up, start grounding, then your oiler next. And then even as you're an oiler, you'll get plenty of operating time. A 12-hour shift, oiler usually will run the dragline for 4 hours of that.
Right, because all 3 positions can operate the dragline, right?
Yep, definitely at some point. If you get a new groundman or something, they might not have the training yet to run it, but eventually they will, for sure.
The dragline operates in 2 12-hour shifts, from 7 a.m. to 7 p.m., and then from 7 p.m. to 7 a.m. Since these machines clear the way for the coal mining, running them 24/7 is essential. The relief crew gets ready to head out from the office around 6:30 a.m. and arrives at the machine around 6:45. Once 7 o'clock hits, the crews switch, and the massive operation of removing overburden continues. At this time of year, the crew switch happens right around sunrise, and boy, was it a sunrise. With the sun up in the sky, the dragline was getting close to finishing this section of overburden. So that meant it was time to walk the machine. And yes, I mean the machine literally walks. Well, it's more so of a scoot, but you'll see what I mean. Because the dragline weighs over 6,000 tons, the only way it can move is by using its two giant shoes to lift half the machine off the ground and propel itself forward. Let's talk about the process on site. We're back in business. We're here to make a video for you all of that machine right there. Before we get onto the machine, they are moving it as we speak. You can see the Groundman right there in that little John Deere tractor. He is moving the power cable out of the way. This is an electric machine. They power it via the power station that this whole mine facilitates, feeds, which is awesome. Very cheap, affordable power to run such a monster. So the giant extension cable, the trailing cable leading to the machine, that's the most delicate part of this operation. You've got to be really careful. You don't want to be stomping on it. That tractor moves it out of the way nice and gently. And then the machine there is taken, I think, about 16 steps further back to give them a little bit more working area for this morning's shift. Each step 42 seconds for 8 feet at a time. The machine doesn't actually leave the ground. It is dragging itself along that tub on the bottom. The front is lifting up, but the back is staying on the earth. That's a very, very heavy machine. It can't fully lift itself.
One cycle moves both shoes at the exact same time. They're synchronized. If they're out of time, the machine can't move.
This is a 8200?
Bucyrus Series 2570.
A 2570.
2570. All three of our drag lines are identical.
They're Bucyrus here. They're moving about 50 feet right now?
Yeah, he's going to move back to his landing spot and then they'll be ready to start their next lift. Yep. Roughly 20 steps, which would be 160 feet
Okay.
of travel. Yep.
It's really not that slow in the grand scheme of things.
You might know it better than I do, Aaron. There's a number given, like 0.2 miles an hour,
Yeah.
which is 8 feet every 40 seconds.
Yeah, I mean, it's not fast,
Yeah.
but considering how big the machine is, it's not slow.
It's very rare that they have to move a really long distance. This drag line will dig this pit and then come back to the other end, so it does have a full day of travel built in there. Yep.
It is just so funny watching that thing walk.
Every time I see it move, it's like, can't believe it works like that. There's a spray bar across the back that waters the ground right where the tub is going to move. Part of it is to reduce friction as the tub drags along the ground. A secondary reason is it reduces static electricity buildup if there is too much friction with the tub and the ground. So
I didn't actually know that. I didn't realize there was water.
yeah, the water sprays out of that. It's part of the cycle. It's not like he has to press a button or anything. Right when it goes, it turns on at a specific time and off.
Oh, yeah.
Yeah, it's part of the step cycle. So very cool. Depending on conditions, the big water tank in the dragline gets filled by a water truck that comes out every so often, depending on how often they're walking. So.
With such a big machine, one of the most important members of the crew, one of the three, is the Groundman. The Groundman has 3 different tools to perform their task. First tool is this little green tractor. The little green tractor is to move the dragline's power cable wherever it needs to, stay out of the way, to be safe, to power the machine. second tool is the Caterpillar, typically a D10 dozer, sometimes a D11 dozer. That machine has two primary functions. One, it smooths out the pad for the dragline, which needs to be nice and level so that the machine can be steady as it's digging. And two, it will clean the pit floor to enable the dragline to dump the spoils into the previously mined area without that material going anywhere. And then the third tool the Groundman has is these right here. Their feet. They walk around. They are the operators, the dragline operators' eyes and ears on the ground, which requires them to be on the ground, walking around the machine, oftentimes to ensure the machine is where it needs to be, the ground is stable, the power cable is out of the way, etc. As you've seen, they're communicating nonstop via radio. Now that we have a rough idea of what the Groundman does, let's talk to Dakota, Groundman for the Missouri Quest, and dive deeper into his responsibilities.
We're looking right to the east right there where he's dumping. So that will be our next bench for the next pit.
Where he's dumping?
Yep, where he's dumping. And he'll throw that out and rake it down, and then dozer will go over and do finish work and make sure it's wide enough and level enough for us to be able to sit on the next pit. Well, we keep in constant communication with each other. You know, I got my handheld radio on me and on at all times, and then in the dozer and in the tractor, we got radios in there too to communicate, but every day might not be the same. You still got your basic things that you gotta do, which is build the bench behind the machine, clean and rip pit floor, and then build our return bench. On day shift, you know, the previous night shift might be sitting where we are now, and the first thing I gotta do is hop over there and go build return bench, where the day before I had to go down and work on pit floor. You gotta try to stay one step ahead, because if I'm over on our return bench working on that and don't have the bench behind the machine built and ready to go, once they're done throwing the dirt off their face and they want to come off a point, there's nowhere for them to go.
Walk me through the process of, like, the machine's about to walk and you have to move the cable. How do you do that?
The power cable is heavy.
Oh,
I don't remember what they say it is. If it's 40 pounds a foot, it is. It's very, very heavy. To where we got to use a tractor with a D-ring on it to maneuver it. On the back of the dragline, on both sides, there is a chain hoist that we use in accompanying the tractor to move the cable. It took me quite a while to get used to moving cable. It's all a visual, mental angle game. You gotta finesse it a little bit. You know, you back into the cable and it starts to bow, and sometimes you can turn and, you know, reposition it, and then you pull ahead and you get your D-ring over the back, and then you can grab it and pull it. Trying to figure out where to grab this cable at so that I don't have to move it a whole bunch of times in order to get it from our call sign to our cable tree. So I'll back up into this cable, roughly halfway, give her a slight angle. Another bite on it. position and angle, and it just takes practice. You don't want to cut anything. You don't want to rip anything. You don't want that dragline to lose power. It's almost a pride thing too. After you get your cable moved and repositioned to try to make it look a little pretty also. You're always looking behind you. Make sure that you're grabbing the appropriate amount of cable.
Okay, everybody. They've walked it. It's time to get back to digging, but first, we're gonna get on board. After talking with the operator of the Sakakawea dragline the previous morning, it was time to speak with Kip, one of the operators of the Missouri Quest dragline. The hydraulic ladder came down to meet us, and we all climbed up into the belly of the beast to see how it worked up close.
Hey there.
You're the dude, huh? You're famous.
Something like
Nice
that.
to meet you, Kip.
Good to see you.
So you guys get all over the place.
All over.
Crazy, yeah. I've seen
Yeah.
it on the internet. Pretty awesome.
Yeah, we go all over. We're spoiled.
So you're building a pad right there?
Correct. What we're doing is we're building our next bench for our next pit.
It's just so deceiving how much material that is.
So it didn't have a.
You know, you take one bucket of dirt, you dump it out there. You take your average skid steer, it take you days to flatten it out. You know, it's just crazy. And it is for me. I've been here for 15 years on the dragline. 15. And still to this day, I was a groundman, oiler, operator.
Okay.
So a total of 15 years. But for me, you know, there's times I got to step back and it's just hard to believe how massive this is.
Yeah.
You know, the power, the amount of dirt you're moving. You're constantly having to pay attention to what you're doing. You know, you can't just let go of the sticks.
Sure.
Because you're basically, that bucket's just an extension of your arm. So you never really, it does get boring. For me, it don't anyways. Actually, it's enjoyable just to sit here and dig.
I bet. So when you're moving the material, it's a combination of these are your drag ropes, right?
Correct.
It's a combination of that and then just the weight of the bucket itself doing the digging.
Yep.
Because the weight, I mean, just dropping that or pulling that through the earth alone is a lot.
Enormous amount of energy it takes to pull this.
Yeah.
The bucket in itself is just heavy.
Sure.
You know, by just sitting the bucket on the ground, you're taking a lot of weight off that boom. Sometimes we walk, we'll set it on the ground. If we're starting to drag dirt or pull dirt, that'll take a little bit of the weight off the boom and we won't drag as much dirt with us.
How long does it take to really learn how to be effective on this?
You know, to be able to be smooth and efficient
Yeah.
and fast takes time. Some people pick it up really fast. Others, it takes more time. But for me, it took me a couple years before I got to where I feel confident in it.
A couple of years. Wow. Because as you go too, are you listening to the machine?
Yep. You know, squeals, like sometimes you can hear a squeal from the back, you have a bearing going out, or you know, we're always listening for all kinds of noises.
Sure. In a good shift, how much material will you move?
Our projection is 50,000, but there's times 80,000, 90,000.
How close to the coal do you aim to get? Like within a few feet, a foot?
We'll take it right to coal.
To coal?
Yep, take it right down to coal. We take it to coal, then they'll bring in a rubber tire dozer, and they will take the rest off. Clean it, basically.
Do you do that visually?
Yep.
Kip then offered us the opportunity to walk the boom, and we will, but first we returned to ground level to see the mechanics perform their weekly bucket inspection.
So that's how you grease it, a Milwaukee greaser for a dragline.
Yeah.
Who would have thought? How often do you have to grease all this? Like once a day?
We do it Monday and Fridays.
Okay.
Yeah, once or twice a week.
Yeah, that's not so bad.
And we'll walk the boom too on Fridays and whatnot.
Is it just one zert per pin?
Yeah, you got one per pin, and then you have two on your dump shivs.
Okay. Is it just one tube, or do you have to go through a few of them?
We go through a few.
Yeah.
I mean, it depends on how much. It depends on how much a guy does, I guess. Usually 2 or 3 tubes here.
It's like it needs it now.
So same stuff you grease a skid steer with. I love it. Well, there you have it, folks. A Milwaukee battery greaser to grease your dragline. Have you already looked over the bucket?
Yep.
Oh, what do you when you look at the bucket? Are you just looking for anything like obviously wrong?
Tracks, and check all these keepers, make sure there's bolts in them.
The keepers?
Yep. They pulled the pins on, I guess.
I see. So it's just a quick once over, making sure nothing's obviously out of whack.
Yeah, pretty much.
They change the massive teeth out on the massive bucket about every 3 weeks. Additionally, North American Coal maintains multiple buckets on site at all times. They swap the buckets out on average every 6 months. Once a bucket is worn, welders spend months rebuilding it in a special on-site shop to the required specifications before putting it back into service.
Yeah, it's pretty good here.
It's like my living room.
Yeah, this is, I would say, I mean, about the size of my house, really. Like, my house is not a whole lot bigger than this. I mean, yeah, it's about the size of my house. I'm not joking. My house isn't as dirty, though.
To put this 123 cubic yard bucket in perspective, it can hold about 120 washing machines, and the chains that hold the bucket aren't exactly from your local Home Depot.
Such an enormous bucket and tooth needs something for a little bit of scale. Fortunately, I've got my Ariat boots right here, my specialty. Shout out to Ariat, the channel sponsor. Mid-morning inspection completed. Before we get back into the Magic School Bus, board the machine, check out the insides. This is the drag rope. So there are 4 ropes on the machine that make it work. 2 drag, goes in and out, pulls the bucket in towards the machine, out from the machine. And then you've got your hoist ropes from the very top of the boom where we just were. And they're solid steel cable, pretty enormous.
Now that we know the bucket is in great shape and the grease points are all hit, it's time to get our steps in and walk to the top of the 340-foot boom.
I've been offered to go up the boom many times over. I never have done it, but today I guess I will.
There she is.
All right, we're gonna go walk up the boom now. I've never done this. I've always politely declined, but figured today's the day. Yeah, this is a good workout, huh?
Yeah.
I don't know if I like this very much. I'll let him go up there. We don't need to go up there. Yeah, I'm not gonna need my jacket anymore after this.
I took mine off 'cause I knew I'd get winded.
Yeah.
I had to stop about 3 times.
Well, it's such an awkward,
Thank you.
it's such an awkward distance between the steps.
The final?
Yeah. How high up are we right now? 300 something foot.
Yeah.
Safely 300 foot.
We'd have to look to give you the exact. Yeah, all the way to the top right there. Go ahead, I'll. Okay, I'll catch you later. Yeah, all looks good.
We are officially at the top of the Missouri Quest dragline. After checking on my house in Tennessee from climbing about 1/3 of the Empire State Building, we climbed down and took a group photo inside the giant bucket before heading back to work. Now that we're acquainted with the building-sized Earthmover, how does it all run? First is the giant extension cord, which travels thousands of feet to an on-site substation. About the diameter of a soda can, its 23,000 volts travels to the machine from the very power station it helps feed. The outer bits of the machine are simple and obvious, but the magic happens within the house, which is more like a warehouse where all the motors and components lie. From the inside of the house, we have the swing motors toward the front, which swing the machine side to side by turning enormous gears. In the middle are the two cable drums, which drive the bucket functions via the drag and hoist cables. 8 electric motors drive each drum. To pull the bucket in, the drum reels in the 2 drag cables. To lift the bucket, the other drum reels in the hoist cables. For the opposite functions, the drums turn in the opposite direction, feeding more cable out of the machine. And before we move on, Wyatt and Drew had a little fun and tried to attach a camera to the bucket. We were pretty happy with the results. We talked about the operator and the groundman, but what about the oiler? Since the machine shuts down for inspection, we spent some time with oiler Jared as he fired everything back up before digging resumed.
So basically what I'm doing right now is when we park for inspection, maintenance, we lock out air for each main component, the drag, the hoist, and the swing.
Okay.
That way there's no way for these brakes to release. It cuts off air pressure to them.
I see.
And then I'll show you back there, we cut off the electrical signal to send from the joysticks, the cab, the excitation to the machine. So there's no possible way for this machine to move while we're working on it.
Interesting.
It's part of our lockout tagout program, just a safety precaution so nobody gets hurt.
Sweet.
While we're working on the machine. This is for the hoist drum. That releases air to the drags, this releases air to the hoist.
Okay.
And now we'll release air to the swings. So this cuts off excitation, so we can't send any electrical current to the motors.
Okay.
Because it's just basically a breaker to, so basically stand back, pop the breaker, and then turn the dial. Always want to stay clear of the other glass because something blows in there, sparks go flying. You ready to go make some noise?
Oh yeah.
I've been on the mine since 2017. I've been on this machine for about 2.5 years.
Really?
Started as a groundman and got an oiler bit about 1.5 years ago. So
Do you know like every square inch of it now?
absolutely not. There's so many moving parts on this machine. You learn something new every day. There's 8 motors per drum that drive. There's 8 hoist motors that drive the hoist drum. There's 8 motors that drive the drag drum, but there's only 4 motors for the swings.
So 8, 8, and 4.
Yep. And then back what we're about to fire up is the generators, which sends power to every motor in here. And some of our generators, when we're walking, like our drag generators, send power to the propels.
Yeah.
So whenever you guys are ready, we'll go fire her up. So this is where the magic happens. So basically what we'll do, we'll start up the excitation of the machine. And then we'll go through, like this set will start up this row of generators. This set will start up this row of generators, and so on and so forth.
Okay.
And you'll see, you can watch these gauges, and you'll see the lights flicker because it draws so much power to fire these up.
And so that's why there's the cooling on the back that you see when you're looking outside.
Yep.
Because the generators are here.
These are actually exhaust ones.
Yes.
These ones up there are the intakes.
Okay.
Those bring the air down. You guys ready?
Yep.
Nope, sir. Nope. You're not?
I'm ready.
All right.
So we'll fire that up, let it sit for about 30 seconds to a minute, and then we'll start firing up the generators. We'll start this row right here first.
While getting the shots from inside the dragline, we hit a little snag.
Yeah, one of these.
What?
Or they're digging. All of a sudden they hear something.
Well, what did we learn, Drew?
Nothing.
Oh, man.
The oiler is the machine's doctor and therapist and dietitian. He keeps the giant machine running smoothly. Every hour, every shift, while the operator swings nonstop, he's checking the cables, motors the size of cars, and gearboxes big enough to live in. Constant movement is the game. Greasing, inspections, and listening are the norm. And when that's all done, he's got a bucket and mop in hand, keeping the place immaculate. A machine from the 80s doesn't look this clean by accident. So that's how this machine works, and that's who makes it happen. All three draglines here at the Freedom Mine run the same way, with the means and methods honed over decades of nonstop operation. The mining process requires the same methodology, with every bucket the dragline digs planned months or years in advance. The dragline crew not only constantly communicates with one another, but also with all other operations around the machine, starting with pre-stripping. Smaller excavators like the PC2000 and scrapers remove topsoil and subsoil ahead of the mining operations. Trucks then haul this material to the previously mined portion of the mine for placement, allowing for complete reclamation following the mining process. Once the dragline does the heavy lifting, removing most of the overburden to expose the coal, the mining crews step in with dozers to rip the coal and huge loaders and coal haulers to get the valuable commodity to the power station. As mentioned, once the dragline places overburden in the previously mined strip and the reclamation crews shape the land and replace the topsoil, replanting occurs every spring to restore the land to its natural and even better state. Even though mining has happened here for over 40 years, it's impossible to tell what has and hasn't been mined to the untrained eye.
A very big thank you to the very fine folks at North American Coal and NACCO. They give us the best access of any mining company in the world. This mine is among my favorite mines in the world for a very good reason. Very good people, very good mining, very cool equipment. I hope you enjoyed this video as much as we did, and we'll see you on the next one. Stay dirty, everybody.